Okay. Hello, everyone. This is your digital electronics lab class. Okay. And so far we have seen the adder subtractor and multiplexer, demultiplexer, and today we'll see the flip-flop portion. It is one type of flip-flop we'll see, and that was SR flip-flop. Okay. So, at the very beginning of this portion, that is in this chapter, we have seen what is latch, SR latch. Then we have studied the SL flip flop and D flip flop. Okay, and today we'll see that how the SR flip flop can store a bit. Okay, I have already told that flip-flop is the basic building block of a memory element of a memory device. Means we use the memory devices in so many equipments, but flip-flop is the thing which will helps us to store the data. Okay, so the topic of discussion for today's class will be how the flip-flop can store a bit data. We have seen it theoretically that uh, how flip-flop can store the previous state value, and we can get that value on the next state. How it is possible, we have seen that in theoretically, but I have prepared one video from our lab. Actually, the problem is in our lab there is no internet connection. Okay, Wi-Fi connection. Sometime it reaches there, sometime it's cut off. So that's why I need to go to lab. I need to prepare all the videos, and then I recorded it. Okay, and then I show it to you from this class. Okay, so I have already prepared that video, and I'll show it to you. So the main thing will be how the flip-flop can store the data. You can see that after connecting all the circuits, we will give some combinations like 0 and 1 to the R and S input, and we will see that when we change the input, that is, we change from 1 to 0. Say suppose R, in case of R, we are changing the value from 1 to 0, and in case of S also we are changing the value, but the value whatever was there in the previous state, that will remain constant. Means that is not changing. Okay, though the input has been changed, but the output will be same. This is how we store the data in flip-flop. So this thing we'll see practically. Okay, so let's see the video. Okay, then if you have any issues, we'll discuss it. But before that, let me show you the video. It will be near about 20 to 25 minutes video, I hope. Let me share my screen, and you will get to see the video. Just wait for a while. Yeah. Okay, so I am playing the video. Okay, please see it, and you can ask any question in between in between this time if you have any questions. Okay, so I'm starting the video. Hello, this is Digital Electronics Lab, and today we are discussing about flip-flops. Okay, so I have already given all the details about the flip-flop. What is flip-flop? We have studied what is latch first. Okay, so when you want to start. Achha, yeah, is it audible? Is the video is audible? Please response anyone.
Yes, sir.
Yeah. Okay. The flip-flop you need to study the latch first. Okay. If your concept of latch is very much clear, then you can study the flip-flops. Okay, because there is a simple difference between a flip-flop and a latch is we use the clock signal in case of flip-flop, but we don't use any clock signal in latch. Okay, so the latch is the basic of flip-flop. So before studying the flip-flop, we need to study the latch first. So we have studied the SR latch, we have studied what is SR flip-flop, then we have studied D flip-flop, and then we have studied JK flip-flop and D flip-flop. But today we will perform an experiment which is SR flip-flop and D flip-flop. If we get time, we will cover both the flip-flop, okay, and then we move forward. So flip-flop is a basic memory element, you can say. Okay, we can store a digital data or digital digit in flip-flops. Okay, we have seen how we can store the data in flip-flops. We have seen all these things, but today we see the laboratory. Okay, so as I have already told earlier that we can perform the experiments in so many ways. Like we can use software tools. Okay, we can use breadboards to build the board circuit, and then perform the experiment. And we can use the ready-made kit. Okay, so that we can easily perform the laboratory. So we will use the breadboard and ICs to build the circuit later. But before that, I want to give a clear idea that how to perform the laboratory. That's why we are using the kit. Okay, once we have completed all the experiment using kit, then we move forward towards the breadboard. So let me give a very basic idea about what is breadboard. As I have already told that we will use breadboard to perform the experiment. So this is a breadboard, okay, and all these things are basically digital IC. These are ICs. ICs are there, okay, and this board is called breadboard, okay, where we can perform all the experiments. So in this digital IC, you can see there are certain number is written over here. Okay, if it is not clear, I will show you later. So there are some certain numbers are written over here by which you can easily identify which IC is this. So here it is 7404 is written over here. So we can easily understand that this is a NOT gate IC. 7404 is for NOT gate. If it is 7400, then it is NAND gate IC. Okay, so this is how we can easily identify any particular IC. Okay, and there are certain numbers, certain pins are there. Okay, we need to know what the pin signifies. All these things we'll go in detail with the IC. Okay, and the breadboard later in later classes. But I'm just showing you the IC and the breadboard so that you can have a basic idea that what we're going to use to perform the experiments. Okay, once we have completed the kit. So this is what, okay, you please keep in mind, this is breadboard and this is IC, and with the help of this breadboard and IC and connecting wires, connecting wires are there, and with this help of connecting wires we can build the IC and we can easily perform the laboratories. But when we want to perform the laboratories using breadboard, we need to we need a power supply. Okay, so that we can give a VCC and ground. We can connect VCC and ground with the IC, because when you use the IC, you need to connect a VCC, that is power supply for that IC, and a ground terminal is also there. Okay, we'll go in detail about all this detail on later classes. Okay, but today we will use this kit. You can see here, and we will be familiar with this kind of kits as we have performed the experiment before experiment. So let's see what is SR flip-flop and what is D flip-flop. But one thing you should know that concept of latch is very much important. Okay, because we will go a little bit faster to develop this truth table and circuit diagrams. So if the concept of latch is clear to you, it will be easier for you. Okay. So let's draw the circuit diagram and truth tables, and let's verify it with the help of gate so that we can easily complete the whole experiment. Okay. So please concentrate on my copy. I'll show you a little white. Okay. I hope my copy is now visible. So SR latch, SR flip flop, sorry. So we'll discuss SR flip flop. Okay, and quickly we'll draw the whole circuit. Let me first draw the latch portion. So we are using NAND gate to develop this flip flop. It is SR flip flop. So okay, now we need to connect the output terminal to the input of this first NAND gate. We'll do the same thing with the second NAND gate also. So this portion is basically latch portion. Okay. Now we need to connect the clock. To connect the clock with this circuit, we'll use this NAND gate, the first stage, and here we will connect the clock. This is clock signal. This is, you can say, S. This is R. Okay. I'll not go in detail how this flip-flop will work because I have already discussed the concept that how this flip-flop will work in the previous classes. Now we have two output, that is Q and Q bar. Okay. Now we can easily develop the truth table, and to develop this truth table you need to keep in mind the truth table of NAND gate. So I am writing the NAND gate truth table also. So in NAND gate, if it is AB and Y is the output, we can write the combination first, and then we can easily understand when it is any input is 0, the output will be 1. So this is the truth table for NAND gate. Okay. So now with the help of this truth table, we can easily analyze the whole circuit, and we can easily build the characteristics table. Let me write down the characteristics table. So now we'll write down the characteristics table, and characteristics table will contain Q, S, and R. I hope all these things are clear to you. Now this is Qt plus 1. You can write it is in suffix. So now the combination I need to write 0 0 0 0 1 0. Sorry, 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1 1 2 3 4 5 6 7 8. So okay. So now we have 8 combinations, as we have 3 input like Q, S, R. Okay. Now we need to write down the output, that is next state, that is Q T plus 1. Write down it quickly, 0 0. So it will be 0 0 0, then 1 0. I hope it's clear to you. It will be 0. It will be don't care condition, because if Q is 0, this 0 will appear here, and both the inputs are 1. If both the inputs are 1, then we'll get 0 at the output section. And then if any input is 0, then the output will be 1. That means in both the cases we will get 1 1, and it is not possible. So that's why it's don't care. Then 0 0 will get 1, then 1 0 will get 0, 1, then again 1 1, so we'll get don't care. So this is how we build the characteristics table, and I can take Carnot map to build the equation for that SR flip flop. So quickly let's take the Carnot map. It will be Q SR, and as it is 3 variable are there, so it will be 4 boxes will be there in Carnot map, 1 2 3 4. Okay, now it is 0 0 0 1 1 0 and 1 1, and it's 0 1. So quickly write down the don't care is there, 1 is there, then in 1 is there, don't care 1. So this is how we build the Carnot map. Now we have taken the pair. I have given all the details in our theory classes that how we can make pair, how we can build the sorry, I should write it in suffix. So Q T plus 1, it will be S plus Q R bar, because R is not changing over here for this pair. Okay. Now this is the equation. Now we can easily write the excitation table is at Q T plus 1. Okay. Now combinations are 0 0 0 1 1 0 1 1, and the first step Qt plus 1 will get the previous step, that is Qt. Then we'll get, you can easily build this table using this table. Okay, I have told you. So it will be 0, it is 1, now it is don't care. So this is the excitation table, and lastly we will have at least we should write down the truth table first. Okay, I have just forgot it. It is on my head, but I just forgot it. So let's write down the truth table quickly. So the truth table will be clock will be there, then S and R, and output will be next state Qt plus 1. Okay, so it will be 0, don't care. Firstly you will take don't care, then 0 0 0 1 1 0 1 1, and all the classes will give 1 in case of clock signal. And what will be the output in first cases? It is don't care, so you will get the previous state. 0 0 again you will get the previous state, then 0 1 0 1 0 will be there, 1 will be there, and lastly it will be invalid. So this is the truth table for SR flip-flop. Okay, now let's build the circuit, and then let's perform the experiment. I can show you the kit. This is the kit where I will do the experiments. Okay, so in this portion you can see this is SR flip-flop, this is D flip-flop. Okay, and here it is JK flip-flop and D flip-flop. Okay. So we will discuss about JK flip-flop first, then if we got time, then we will discuss about D flip-flop. Okay, but in theory classes we have discussed that what is the difference between SR flip-flop and D flip-flop. There is a very minor difference, which is we placed a NOT gate over here. Here you can see the NOT gate. Okay, so the both input of SR flip-flop, if we placed a NOT gate, then it becomes the D flip-flop, and this is how we can overcome the problem which we face in case of SR flip-flop. I have discussed on detail in the theory classes. Okay, so this flip-flop can also be turned into D flip-flop, and how we can turn into D flip-flop? We have to place a NOT gate in between these two terminals. Okay, so this will be the D input. Okay, and there will be a NOT gate. Okay, there will be a NOT gate, and then it will be connected with the S terminal, and then it will become the D flip-flop. Okay, this is how we can easily convert the SR flip-flop to D flip-flop. And another point I should mention that here we have taken the NOR gate. It is given NOR gate. Okay, but we can easily develop this whole circuit using NAND gate also. If we take NAND gate over here and here in place of this two NOR gate, if we use NAND gate, then this should be also NAND gate. Okay, this is basically AND gate, but if we take NAND gate over here, this gate will be also NAND gate. If we take NAND gate over here, this gate also will be NAND gate. So this is the main difference between NOR SR flip-flop and NAND SR flip-flop. Okay, if we take NAND gate, this will be NAND gate. We are taking here NOR gate, so this is AND gate. So this is the difference. And as we already know that this is the output panel where you can see the output signals. Okay, and this is the input panel from where we will give the input. Now let's build a circuit. So we'll use this kind of wire to connect the circuit. Okay, so we have to give the clock first. So this is clock, you can see here. You can give clock so many ways, but here it is already embedded. So we will give not a clock signal from here to here. It is already mentioned over here, you can see. But when we will build the whole circuit in breadboard, you should keep in mind which terminal is clock and which terminal is R and S. Okay? And we have to arrange an external clock signal for the particular IC in case of breadboard. So this is this kind of difficulties we will face when we will use the breadboard. But in case of kit, it is already embedded inside this kit. Okay, and now we'll give the input one, that is R, and this is S. This is S. So we'll take the output also from this terminal like Q. This will show Q, and this will show Q bar. This will show Q bar. Okay. So now we have already built the whole circuit. This R is nothing but this is. This S is nothing but this is. This clock, we have already given the clock from the kit itself. This is your Q output and this is Q bar. Okay, now let's switch on the device. So it is initially showing the previous state. Okay, this LED is glowing. So this is the previous state. Okay, and we have given 0 0. Now if we place it 0 1, you can see the changes. Okay, now if we change again the state, that is from 0 1 to 1 0, it is already changing. Okay, when we will give 0 0, now we are giving 0 0. You can see it stores the data. It's not changing. Okay, this is not changing. We have given 0 0 and it stores the previous data. But when we are again start from beginning, we have given 1 1, so it's basically invalid. Now 0 1. In case of 0 1, Q is 0 and Q bar is Q is 1 and Q bar is 0. Then we'll change it to 0 0. Now we have changed it 0 0, and you can see this data is stored. It is not changing. That means the previous state, whatever the value of the previous state, it is storing that data. When we are giving 0 0, it's not changing. Again, let's give 1 0. So this data is now with us 1 0 1. We are giving 0 1, we are giving 1 0 to the input, and we have got 0 1 at the output terminal. Okay, now we want to store this data. That means we will change the input, but output data will be stored. That means it will be 0 1 only. So now give 0 0. I have given 0 0, but you can see at the output terminal it is 0 1. That means the previous state, whatever value was there in the previous state, that is when we are giving 1 0, that value is stored. Okay, got the concept? Now if we give again 1 0 1 0, so this is the value. Now we are giving 0 0 1. You can see here it's 0 now, it's 1 now. Now its value is 1 0, and now we want to store this 1 0 value. What we will give? We'll give 0 0 to the input, and we can easily see that the output data is not changing. That is, now also it is 1 0, and the previous state also it was 1 0. Now you can see that the input is changing. The input is changing, but it stored the previous data. Okay, so this is how a flip-flop basically store a data. Okay, this is it, and we will discuss the rest of the portion on the later class. Thank you, everyone. Yeah. So I hope everyone got the concept uh, that how a flip-flop can store a data. Initially, we have given a particular value. We have made s equal to 1 and r equal to 0, and we have got certain value. In q output, we have got 0, and q bar it was 1. And when we want to store this data, we need to give 0 0. Okay, you can see, if you can see your class note, you'll find that we have studied 3 cases. Okay, we have studied 3 cases, and initial case it was r was 0 or s was 0 or r was 1, and then we got some certain amount of value in the output in q and q bar. And now whatever value is there in case of q and q bar, we want to store that value. And how we can store that value? We change the input from 0 1 to 0 0, and we can find that in case of 0 1 it was 1 0, and in case of 0 0 also it is 1 0. That means it's storing the data. Okay, so this is the concept of flip-flop. Okay, so is there any issues regarding this? If you have any questions or any issues, you can ask, or I'll stop the recording now. Then I'll take some question answer and I'll record the attendance. Okay, Animesh, thank you. I'm stopping the recording now.